Alright, we're moving on to diagram number 5, which is the Earth clock. Now, you need to be really careful when you're doing time because you have to look at the perspective. If you have a top view or a north polar view, you're looking at 360 degrees of longitude. You're going to be able to see the entire you're going to see half of the Earth is lit and half of the Earth is dark, but you're going to get in all 360 degrees of longitude. So from this perspective, you actually get all 24 hours of time, and you should be able to find 15 degrees per hour for each of the time zones. All right, every 15 degrees you move, you change your time. I hope you've heard that west is earlier and east is later. Now, once again, it's helpful to look at the Terminator. So since the light and the vertical ray is coming from this side, you'll notice that half of the Earth is illuminated and half is in darkness. So I'm shading in this portion. All right, this part is in darkness. All right, now you can actually tell the season from this diagram. Okay, on this diagram, when I'm shading this, you see the North Pole is on the Terminator. And the only day of the year, and we picked this intentionally because it makes it easier, the only day of the year when the North Pole is directly on the Terminator is going to be an equinox. So this one, what type of season does this diagram represent? This has to be an equinox. Every single line of latitude, the circles are the latitude lines, but every single line of latitude is half in the light and half in the darkness, which means 12 hours of daylight and 12 hours of darkness. If you are at the position directly underneath the vertical ray, if you're completely facing the light, that's when you get noon. So point C is going to be at noon. I hope you know that noon is 12 p.m. So on this diagram, point C is definitely at noon. Okay, so the time here would be 12 p.m. Now, whatever point is completely opposite the sun's rays, okay, is going to be point G. Okay, it would take 12 hours to rotate half of the way around the planet and get to point G. So point G is going to be at 12 a.m. All right, so when I'm looking at G, I'm going to put this in at 12 a.m. Now, they didn't draw the arrows, but it would be really helpful that you can picture that the Earth is rotating from west to east. In this diagram, it's moving this way. So point E would be sliding through the Terminator. The point, the city, that location would be moving from the dark into the light. They would be experiencing sunrise. Honestly, it's an equinox and it's the equator. Okay, the outer largest circle here is the equator, and every single point on this diagram, the labeled letters are all exactly on the equator. But point E would be rotating into the light, so point E would be at sunrise, it would be at 6 a.m. I'm fairly confident that you can figure out what point A would be. Point A is on the Terminator, it's moving from light to dark. Okay, at the equator you always get 12 hours of daylight and 12 hours of darkness, so point A would have to be 6 p.m. Each one of these is 45 degrees apart. Okay, I hope you realize that you're moving at 15 degrees per hour, so 45 degrees would equal 3 hours difference. And I'll let you finish the rest. You really just have to be careful with these diagrams to figure out if the North Pole is in the middle, if you're looking at the top view and getting 24 hours. If the North Pole is on the top and the South Pole is on the bottom, that's the next diagram. That means you're going to be getting only 12 hours of time from what you see. All right, that was diagram 5.